So I'll do Armstrong numbers in Python with unit testing, and I'll do some pairs just unit testing. So Armstrong numbers, what'd you all think of this one?
I liked it. We did it in Java. It was a fun challenge.
Java?
Or JavaScript, sorry. My bad.
Well, you're ahead of the game. Oh. Yeah.
But yeah, liked it, because it's like a kind of a complicated thing. You got to like, we did it by destructuring it into arrays, doing the math on each individual item, and then summing that back out, comparing it to the actual initial provided value. I don't think we did it super efficiently, but it did work, and that felt good.
That's all that matters. If it works, go ahead.
We ended up changing that. I was Jack's partner. We ended up changing out to like higher order functions too. And it just, I don't know, I felt pretty proud because like it looked like super clean at the end of it. But yeah, I never got to it in Python.
Nice. Awesome. That's fine. All right. So the first thing I'm going to do is fork this over to my personal GitHub, upper right-hand corner, click the fork button, click Tom Preet. It's going to forking over Armstrong numbers to Tom Preet. And while that happens, I'm going to open up a new VS Code window and bring it over here and open up my terminal. I'm going to zoom in. Is that good, or should I zoom in more?
It's looking good, Tom.
Okay, great.
At least to me. I don't know. I can't
If you want me to zoom in, I'll zoom in again. There we go. All right, so first I'm going to CD into my desktop, CP challenges, Oscar challenges. I'm going to list everything out in here. So I've got my previous challenges that I did, 99 bottles, Def Grandma, Get Practice, JavaScript Fundamentals. So I did fork it over. Now I'm going to clone this down, bring it down to my local machine so I can actually write some code. So I'm going to do git clone and paste in that link and clone that down. So now if I list everything down in my current directory, I can see I've got Armstrong 1 there. Why is it Armstrong 1? Oh, okay, because there's 2 Armstrongs. Armstrong run 1. So I'm going to clear the terminal. I'm going to CD into Armstrong 1 by just doing AR tab, and it auto completes it. And now I'm in Armstrong 1. And notice the Armstrong 1 directory has already a Git repo attached to it. So I'm going to list everything out. I've got my JavaScript and my Python. And before I go into my Python, I'm just going to open this up into the current VS Code window. What's the command to open up the current directory into a new VS Code window, Sean?
It's code flag R space I, or space period, sorry.
Space period. All right. Yep. Code space flag R space period. So it's going to reload VS Code window, and it's going to open up Armstrong 1 into my current file explorer. So I'm going to open up the spec file as well as just the actual directory. So I'm going to close the Explorer just so I have some more room. So we just learned some test-driven development yesterday. And we've got these kind of lazy way to test the application right here, but let's convert these into actual unit tests. So convert into actual unit tests. So the first thing I'm going to do is I'm just going to comment this. Actually, I'll just comment that out, and I'll just convert these into unit tests. So what library or module do we need to import for writing unit tests in Python?
Import unit test.
Import unit test.
The import unit test. So import unit. Whoop. Import unit test. I'm going to bring that up there. All right. And I don't know why import could not be resolved. I think that's just a PyLinter issue. My linters, I think, messed up. So this says from Armstrong numbers. So from the Armstrong numbers file, which is this file, import the find Armstrong numbers method, which is right there. All right. So the first thing I'm going to do is create a class based on, I'm actually going to open up the unit test. Unit test documentation Python. So here's the built-in unit test module that already comes with Python. So I don't necessarily know. It's the first time messing around with this. I'm going to just copy this whole thing in here like so. It looks like I already imported unit test, so I can go ahead and delete that. But okay, so looks like this, I just copied this over just kind of so I can get the architectural. So it says test string methods. So it looks like test string methods is a class and it is inheriting, don't worry about what that means, the test case class from the unit test library. That's what this means. Don't worry about it. We'll cover it next week. But let's rename this to something that's a little more descriptive as to what we're specifically test case, writing test cases for. So I'm going to call it Armstrong numbers test case. Sure. And it looks like here it says test upper, takes in the self keyword. Don't know what that means yet. We'll learn more about it next week. All right. So it looks like whatever this method does. All right. So it looks like we have this assert true, assert equal. And we kind of want to, and I noticed that each and every one of these starts with a test underscore. So each unit test must start with the keyword test underscore or test, or else it won't run. So this must start with the word test. So just keep that in mind. So I'm going to first, what's the first thing I should test in Armstrong numbers? Maybe we should read at specifically what we need to actually output.
Yeah, let's just open up the README.
Yep. All right. Write a program Python. So all the Armstrong numbers in the range of 0 to 99. In the example, let's actually look up here. So it looks like it wants to output a list. Okay, so let's first test what the output of Armstrong numbers should be. So test returns a list. So you can do assert equal, and this is what we're testing the function. This is us actually executing the function, and this over here, the second argument should be what the actual output should be. So how do so I'm going to write the function. I'm just going to bring this, find Armstrong numbers, list range through, I'm just going to copy that over to here. So find Armstrong numbers. It looks like, there we go. So I was missing a closing parentheses. So I'm calling find Armstrong numbers. And what is this list parentheses range of 0 through 8?
It's just the Python syntax for making a list with the numbers 0 through 8 in it.
Okay, great. So exactly, it creates an array
list
or a
for
list.
0 through 7.
Yeah, so that's what it should be. So if I want to test the type of what this returns, how do I test whether or not this returns a list?
You just put the second argument. I would just say list. That's Python syntax for an empty list.
Like so. So notice how when I just typed list, I got this thing that says class list built-in mutable sequence. So this is the list class in Python. All right.
Do you also need to change the method call to assert is instance?
Assert is instance. Assert is instance. Is it unit? There we go. So assert is instance. So you can see what this method does. Object class match. I've never used this. So type So test the type. Do I need to use this? How do I actually first test the type of whatever this output is? Because right now this return.
You would
Sorry.
do type, and then its parameter would be the function find Armstrong numbers.
So type. There we go. So I'm actually gonna delete that. And let's just do pass. Let's actually just return an empty list. So I'm back over here in Armstrong numbers, and I'm literally just returning an empty list. And if I execute this, so if I cd into Python directory and run Python Armstrong numbers spec, okay, it looks like it ran test. If I run, does green, I don't know if I installed this yet. Okay. So if you type the word green, I already have this library module installed in Python. It just gives it like a little more. So it ran one unit test right there. So it says ran one unit test in 526, about a half a second, and it passed okay. So cool. All right, I passed that part, but obviously my function isn't where it needs to be. So I'm going to say, just to keep things def, test returns the correct list. Just something that, and I can actually test. Actually, I'm going to do, and above the, in between here, I'm going to actually like write a little more descriptive of what this actually is. So when you call find Armstrong numbers, you should get a list. It should return an array or a list. So I'm going to do that down here as well. So I'm going to just run these. So I'm going to bring that down here. I'm going to convert these into unit tests. So just something's really, when you call, let's see, when you call that one. That one. I thought there was another one. 0, 100. Find Armstrong numbers in this one. So you can actually write multiple tests within a single. So I'm going to run this one. So I'm going to actually write like 3 tests. So self.assert equal. When I call this, I should get back a list of 0 through 7. I'm going to copy that down 2 more times. When I execute that one, where'd it go? I should get a list between 0 and 9. And lastly, if I do 0 through 999, I should get a list. Whoop. Like so.
Hey
looks-
Tom, quick question here. So what's that keyboard that they're using to just replace what you're copying or to paste in?
So like when I highlight something and just paste it in, like
Yes. Yeah, because
Oh.
it's not Command V. That's just paste, but like you're replacing what you're highlighting.
I am just pressing Command V. So I'm highlighting whatever and I'm just pressing Command V, and it
Oh,
is
okay.
replacing it.
Cool. Thanks.
And it looks like I'm missing something here. Looks like I'm missing. There we go. So I'm going to clear the screen, run green Armstrong numbers. Whoa. Oh, it looks like failure. So second list contains 8 elements. First extra element 0. So ran 2 tests. So I only have 2 specific tests. But this second test runs 3 different tests. Ideally, you should have 3 separate tests in here, or have this be one test, have this be another test, and have this one be another test. But just for this example and time's sake, I just have these 3 tests in here. All right, looks like I'm failing the 3 tests, or these 3 tests right here. So let's actually start coding the problem. Does anybody have any questions about
So
setting
if
up?
you have multiple asserts in the same test, it will only test true if all 3 of them are true.
Yep, exactly. So if all 3 of these are true, this test passes. If one of these fails, then this entire test fails. So that's why it's good to have it broken out into more granular test cases. All right. So let's go ahead and I'll actually delete that file right now and start trying to solve it. And before I write any actually code, does anybody know what pseudocode is?
Yeah, that's pretty much kind of like whiteboarding, like you're just explaining or writing down like the steps that you take in order to solve it, and then you go into the actual syntax of solving the problem.
Yep. Exactly. So I'm going to do some pseudocoding before I even start writing anything. So the first thing I'm going to do is write a function or slash method that takes in an argument that is a range of numbers. So it's going to take in a list. And let me look at this. Just look at the example. So for this example, say it takes in a list. So it looks like I'm gonna have to loop through that list at some point. And it returns a list of Armstrong numbers. So maybe I should have an answer variable that just will store a list of Armstrong numbers. So I'm gonna create an answer variable that, don't worry about my spelling, that is that's an array initially. All right. So if our argument is a range of numbers, I'm going to have to iterate through that array. So iterate, just loop through the range of numbers. So as I get to each number, so I need to somehow split up that number to extract each individual number. And I don't think I can do that via number, like with a data type number. I know I can do that with a string. So I'm thinking I have to convert that number to a string, and then I can manipulate it and probably convert it back to a number. Or yeah, that's my initial intuition. All right, so I'm gonna convert each number into a string. What else do I need? I need this exponent, which is the length of the string, or the length of the integer, which is now a string. So I can store that in a variable. So it's the exponent. So I can create a variable called exponent and create a variable. Called exponent and have it equal to the length of the string number. All right, so I have the exponent saved. Now, I can probably, what do I need to do? I need to create, so I've got the exponent. I have the number that's a string. Now I have to break up that string and grab like the first element of that string number, convert it back into a number, and raise it to the exponent power and store that into some sum variable. So, because we need to grab the sum of this as well. So I'm going to create a variable called sum. Create a variable called sum and have its initial value equal to 0. And I'm going to sum all of that up. All right. So what do I need to do next? So I've got the sum, and I'm guessing, can I store?
You got to compare the sum once you've exponentialized each of the terms against the original three-digit number.
Yep. So I also need to loop
through the string, yeah.
Loop through the string, right? And grab convert that number into, or convert that string into a number. All right. Let's see. Let's see, what am I doing? Do I need to convert this number into a string yet? There's actually another way to do this.
Yeah, I'm happy to see what you think.
So So I'm going to create a temporary variable.
The string works out pretty good.
Yeah. So I'm actually going to create a temporary variable that stores a number to extract each individual integer. So think of this. If I take 371 and I do modulus 10, what is that number? What's the remainder of that? 1. Right? And then I can exponent. I can raise that and add it to the sum. And then
You don't have the exponent yet.
yeah, I do. It's right here.
What string?
Oh yeah, there you go. I guess
If you
I can do
integer in an array and then see how long the array is, and then do the exponents.
Yeah, I could also just do all this in one line, just convert it to a string. yeah, just convert this into a string.
That's the fun part about this problem, is deciding what direction to go in.
Yeah. Length of so have it equal to the length of the string number. So I can do like, I can convert the number into a string and grab the length of it all in one line. So I'm going to take a temporary variable that that stores a number to extract each individual integer from the number. So instead of converting it to a string and then reconverting it back into a number, there's a mathematical way I can just extract the number from extract each individual number from the number. All right. And then I'm going to say, I'm going to create a while loop where the temporary variable is greater than 0. So this is where like the math part comes in determining what number, how to extract each number from the variable.
Isn't that saying you don't expect a 0 digit in your input?
No, because here's what I'm going to do. So I'm going to, what this temporary variable is going to be.
Well, your temp is equal to the input value.
Yeah, oh yeah, sorry. Each individual from the number, initial value is input, or is, yeah, that one won't be the input, but like, it'll be like some number. Is number. I'll just say that, num. So now I'm going to find the remainder of the temp variable by using modulus 10 to get the last integer from the, and so I'm going to grab the last integer by doing modulus 10 and store that into a variable called, I'll just call it digit right now, because that's each individual digit. And then I'm going to take the digit variable and take it to the power of the exponent variable and add it to the sum. And then I'm going to reassign the temp variable to the floor of the current temp divided by 10. 10. All right. So, and then divided by 10. And then at the very end, write an if statement that checks if num is equal to sum, and if it's true, add it to the answer array. So let's go through. I'm gonna, so let's see. Temp equals, all right. 1. So let's actually like write this out and see what it looks like. So the first thing I'm going to do is create an answer variable, set it to an empty array, iterate through a loop. So for num and numbers, I'm going to create a variable called exponent, and have it equal to the length of the string. So I'm converting that num. So I'm looping through, I'm grabbing each num, I'm converting that into a string, and then I'm grabbing the length of that. So if it's like 371 here, I'm converting 371 into a string, and I'm grabbing the length of that. I'm creating a variable called sum, adding an initial value to 0, creating a temporary variable that stores the number. So that'd be 371. Initially, I'm just going through as like an example for 371 as the input, or as the as this one. So initially it's 371. I'm saying, hey, while the temp is greater than 0, so initially it's 371 right here. So while temp 371 is greater than 0, where is it greater than 0? Did I create the digit variable? Oh yeah. So right here. All right. So creating a digit variable. I'm taking the temporary, and how do I'm doing modulus 10. So if 371 modulus 10, what is that number equal?
That's going to be equal to the lower order digit over 10.
So it's going to be 1. So 371.
Is it going to be 1 or 0.1?
It'll be 1 because it returns the remainder. So that will equal 1. And then I can do add variable adds to sum. So yeah, take the digit and take it to the power. So sum sum plus equals. I can take the digit, and how do I raise it to the power?
Double
Asterisk.
multiply. Yeah, just do the multiplication
Is it like that?
twice.
Double asterisks.
Double asterisk?
Yeah.
Okay. So I'm raising it to the power of 3. So 1 to the power of 3. So I guess I'll say that equals 3 right there. Great. And now I will divide the temporary number by 10. So if I actually take 371 divided by 10, what is that? What's
That'd be 37.1.
all right? So I've got 37.1. Now I round that down. I take the floor of that. So now it's 37. So how do I grab the floor? How do I round down in Python?
Double
So
division.
just
Yeah, double slash or
All
whatever.
right. So I take temporary division, double slash. Let's like divided by 10. But if I do double slash, you're grabbing the floor. You're taking the temporary number divided by 10 and then rounding that number down. And I can do it in one line. I'm reassigning the temporary variable. So I'm rounding it down. So 37.1, round that down to 37, and I'm reassigning it to the temporary variable. So now a temporary variable is 37. Is 37 greater than 0? Yes, it is. 37 modulus 10 is now 7. So digit is now 7. I take 7 to the power of 3, assign that to the sum, so it adds whatever the previous sum, add 37, or I'm sorry, 7 to the power of 3 on top of that. Take 37 divided by 10 and round down. 37 divided by 10 is 3.7. Round that down. Now the temporary variable is now 3. Take 3, is 3 greater than 0? Yes, it is. 3 modulus, what is 3 modulus 10? Is that
That'd
right?
be
That's
like
still
0.3.
3.
Let's see if this works. 3
That's still
modulus.
3 modulus isn't going to give you a decimal number.
Right, so it's just still 3. 3, power of 3, add that to the sum. Take 3 divided by 10, it's 0.3, round that down, now it's 0. Temp is now 0. Is temp greater than 0? Nope. Break out that while loop, and let's test that. If num equals answer, or what is it? Num equals sum. Answer array dot append. That I'm going to append this number, the actual number, or you can append the sum, but let's just append the number. Then afterwards, when it breaks out of that, when it loops through that range of numbers at the very end, we want to return the answer. So I'm going to clear the terminal. I'm going to Python Armstrong numbers test spec. Ran those 2 tests, I passed those. If you want to see what that looks like actually printed out, I can print Armstrong numbers. Was it list range 0 through 99 or 999? What am I looking at? Am I doing that wrong? Is that syntax wrong? Oh, I need a closing bracket right there. So if I print that out, I'm going to clear the screen down here. Python Armstrong numbers. There we go. We have an array of Armstrong numbers. Did anybody figure that one out? If you did it, if you like converted it to a string, split that string, loop through that string, and converted it back to a number, 100%, that's still 100% correct. This is just another way from a mathematical perspective to do that.
Yeah, we did it that way, not quite as cleanly though.
Yeah, like if you reassigned variables and created more variables to store them temporarily, but
I ended up reading the specifications differently and interpreting it as it taking the max range as an integer and looping from 0 up to the max range. So I made the list inside the function instead. So I had to rewrite the test cases to match.
yeah, and that's okay. Like as long as, yeah, that's totally fine as well. Right. So if I've got this solution now, does anybody have any questions? All right, so I'm gonna check out. I'm gonna check out a branch, Tom's solution. I'll say, yeah, I'll leave it there. So I checked out Tom's solution branch. Git add. I'll add both files. Git status. Oh, I got this pi cache. Maybe I don't want to add that. If I don't want to add a file, there's a couple of ways I can go about doing that. Does anybody know?
You have a local gitignore. You could also set a global gitignore.
Okay. I'm going to add just oh, what, not a folder, a local gitignore. And I think it's just pi cache, something like that. And notice how now it's grayed out. So if I comment that out, now it's highlight, or now it's active almost looking like. But if I type that in here, it's grayed out. That means it's not going to be committed, which is kind of nice. So I'm going to close that out. Clear the terminal, git add. I'll add everything again. Git status. So I've modified those two files. I also added this gitignore file. I'm going to git commit instructor solution, git push origin Tom's solution. So it's pushing that up. Now I'm going to come over here and notice how this automatically kind of updated. Tom's solution has some recent changes. I'm going to compare the pull request. And now I'm in Armstrong numbers. I'm requesting the pull Tom Preet's Armstrong numbers 1, Tom solution branch into the master branch of Armstrong, Oscar Platoon's Armstrong numbers. And I'm going to create that pull request. It's going to run through checking for merge conflicts. Nope, all is good. There we go. Now I can see I've got my instructor solution up there. With that, I'm going to